That means I would take this to be 0. So when I consider delta S, this is delta S by delta H alpha beta times delta H alpha beta plus delta S by delta X mu delta X mu. Okay, what I am doing, that this I am assuming to be 0. Assume so this object T alpha beta would measure the response of the action with respect to the variation of this H alpha beta. The second part is more important, while keeping all other fields unchanged. So here I have only one field X mu, extra field, which I assume that delta X is 0. But supposing I had more fields, like I introduce axion field or U1 gauge field or two form gauge field, like I can do that later on. Gradually you can add other you can introduce more fields into your action. Okay, we are considering the simplest things for our purposes. Okay, but in principle you could add more. If you happen to do that, then also this T alpha beta would measure only this. So this is non-zero, but all other variations would have to be 0. This is how we are defining our energy momentum tensor. So it is slightly different than what we do in our conventional field here. Okay, because here we are defining it just like that. So we are assuming this to be 0, and all such terms, if I have more fields, okay, then variations of all of them we assume to be 0. Okay, that's our definition. So it took me also quite some time to appreciate that, because in my beginning I used to wonder, why doesn't it tally with my exactly like that? But that was more difficult to generalize, and this is the way out. So the string theorists, they consider this T alpha beta exactly in this way, and this is simpler and easier to understand. Okay, so we assume all these rest of the variations to be 0 and only this. So I can even erase this, and we have this, and so this would be then minus d by 2 and d2 sigma. Did I made it disappear? D2 sigma minus d by 2 d2 sigma square root of minus h delta h alpha beta t alpha beta. And if I would equate it to 0, then that would give me the equation of motion of my metric field H alpha beta. Okay, if I would equate it to 0, then that would give me this is the variation in the action, and I am assuming all other variations, variations in all other fields to be 0, except the variation in the metric field H alpha beta. Okay, so this is then, and okay, and we will eventually see this to be equal to minus t by 2 d2 sigma square root of minus h, and my delta h alpha beta would be minus which one is that? 2 omega h alpha beta. We have derived it a little bit short while ago. This delta h alpha beta under the Weyl transformations goes to this, correct? And this times T alpha beta. Here I only wanted to say that if we put it back here, then now you will see that this object is non-zero. My omega is non-zero, this is non-zero, and therefore this would imply to me h alpha beta times T alpha beta equals to 0. Okay. So because if using the variation principle, if this delta S has to go to 0, and if I happen to have this as delta S, and if I equate it to 0, so something has to, this guy is non-zero, this into this is non-zero, so this into this could be 0, and that is true.
But then we also assume that the variation of H is in such a way that the determinant of H doesn't vary. Because H is the action is a function of H has
Yes,
the
yes,
determinant
yes.
as the component. So to vary H, I also have to vary the determinant.
Yes, yes.
So, but
I'm just going to do that.
Ah, okay.
I'm just going to do that. Okay? I'm just going to do that. All right? So, this also in any case will turn out to be true, because this would then be equal to, I mean, we take it separately, H alpha beta into T alpha beta. Okay? But let me first do the variation, including the variation of the determinant. Okay? Yes. So, I can remove this. We remember this result, but let me remove this. So, actually that would give me my definition of T alpha beta. When I also vary the determinant, then that would give me my definition of the detailed definition of T alpha beta. Okay. So yes. So this is what I have precisely now. Okay. So my S is minus T by 2 d2 sigma square root of minus H alpha beta into G alpha beta H is determinant H alpha beta, and delta of I will vary the action. Okay, so then I would use this. Okay, or let me not do it here. I do it at the proper place where I vary the action. So let me vary the action. Delta S. Let me write a little bit small. So this is minus T by 2 d2 sigma G alpha beta into square root of minus H delta H alpha beta plus H alpha beta okay. You were worried about this. Now it's taken properly. Okay. So now we can minus T by 2 d2 sigma into square root of minus H delta X alpha beta J alpha beta plus okay. And now for this, just like you do it for the gravity theory, let me just take it like this at the moment, minus 1/2 times square root of minus H times H alpha beta times, I'm ignoring the derivation of this. You can do it separately, just like you do it in the gravity theory. So here you, instead of H, you consider G and G alpha beta and delta G alpha beta. Just exactly what you do in gravity theory. So this is also a gravitational field. And so this is, I make use of this here. And this, another thing I